Hello everyone, welcome to day 21st of February Lead Code Challenge, and I hope all of you are having a great time. The question that we have in today is majority elements. Here in this question we are given an array of integers and we need to identify the majority element. How do you define a majority element? It's simple. As per the question, it is that particular element which appeared more than n by 2 times in the input array. We can assume that it always exists and we need to simply return that element. Let's walk through a few examples. Here the nums array is given to us as 3, 2, 3. What will be the majority element? That occurs more than n by 2 times. What is the value of n? The value of n is 3. 3 by 2 is 1, 1 plus 1 is 2. So that element that occurs more than or equal to 2 times, which is 3 here. We need to return that as the answer. Similarly, here we need to return 2. Without further ado, let's quickly walk through the presentation and I'll be talking about 3 to 4 approaches to solve this question. Also here there is a constraint that is specified if we can solve this in linear time and order of 1 space. This is the most interesting part. We'll also be talking about this approach as well. So let's get started. Without further ado, let me just start the slideshow. Majority element, lead code 169. It's an easy level question on lead code. However, by virtue of the follow-up, I would like to categorize this in medium category. Let's try and re-understand the question. The majority element is the one that appears more than n by 2 times in the array. Let's take few examples. Here the element are specified as 3, 4, 5, 3, 6, 3, 3. The number of elements that we have in 1, 2, 3, 4, 5, 6, 7. So in total there are 7 elements and we need to identify that particular element which occurs more than n by 2 times. What would be n by 2? N by 2 would be 3. So we are looking for that particular element which occurs at least 4 times in the input array. Here in this case, that element would be 3 because 3 occurs 4 times in the input array. Now let's talk about the first naive approach that comes to everybody's mind. So one can say let's sort this array up, and what do we get after sorting? We get 4 times 3, we get 4, 5, 6, and we can check at what particular fourth position which element occurs. By mean fourth position, the third index. What element exists at the third index, and that element would give you the answer. The time complexity for this particular approach would be n log n, and space complexity would be constant space. This is the first approach. Now let's talk about the second approach. Let me just erase everything, and here what we will do, we'll create the frequency map, which is again pretty straightforward approach. We have solved plenty of questions in the past on this approach. You can store the frequency of each element that exists in your input array in the form of a map, where the key would be the element itself and the value would be the frequency. So what is the frequency of 3? It comes out to be 4. What is the frequency of 4? It comes out to be 1. What is the frequency of 5? It comes out to be 1. What is the frequency of 6? It comes out to be 1. And you can iterate through all the elements and check at what place the frequency happens to be greater than equal to n by 2 plus 1. That would be the position where you need to return the answer. Again, pretty simple and straightforward. No rocket science here. The time complexity of this approach would be order of n. However, you are using extra space for building the map. As a result of it, space complexity also turns out to be of order of n. Now we have seen two different approaches where the time complexity was higher, whereas in the other case there was space complexity of order of n. Can we look out for the best possible approach wherein the space complexity is constant and time complexity is order of n? Yes, it does exist. What is that approach? Let's quickly move on to it. Here I have taken a slightly different example. The elements are as follows: 3, 3, 3, 3, 4, 5, 6. And we are interested in finding that particular element that occurs more than n by 2 times. To be specific, we are looking for something that occurs 4 times in my input array. So n by 2 is 3, more than 3 times happens to be 4, and this is what we are looking for. Now what do? I create a variable and let's call it a count variable or something, and what we will do till the time we are seeing our majority element, we will keep on incrementing the count. Consider this as going uphill on a mountain, and as soon as we see a different element, we start reducing the count by 1 unit, and what will be left in the end? The majority element will be left in the end. How? Let's walk through this case. We see 3 and by default the count value is 1 because it's the first element. Next we see is another 3. We increment the count to 2 because it is equal to the previous element. Next again we see a 3, so the count gets incremented to 3. Then again we see a 3, the count gets incremented to 4. So far we are pretty good. Now what do we do next? We see another 4, which is different from 3, which is not our majority element. What do? We reduce the count. So this time we are going downhill. Next we have 5, we reduce the count. Next we see is 6, again we reduce the count to 1. So what have you observed in this entire process? In the entire process you see that the count value in the end happens to be greater than 0, and it will store the majority element that you assumed in the beginning. So by virtue of the property that the element will exist more than n by 2 times, this algo works. So let's extend it to a general approach. Here I've taken the elements as 3, 4, 5, 3, 6, 3, 3, and let's create that count variable. And whenever we see that my count, the current element in my consideration happens to be our assumed majority element, I increment the count, otherwise I decrement the count. And in case my count gets reduced to 0, I reset my majority element. So here what we will do, we'll create the majority element, and this happens to be right now 3. The count happens to be 1, and let's proceed ahead. We'll start the iteration from the first index up till the last index. So what element do we see? We see 4. Is 4 equal to my majority element? No, it's not equal to my majority element. As a result, what should I do? I will decrement the count. So count gets reduced to 0. I have reduced the count variable by 1 unit. Along with this, I also observed that my count, since it has been reduced to 0, I have to reset my majority element. So whenever the count gets reduced to 0, you have to reset your majority element, because over here it really doesn't occur. So this gets reset to 4, and your counts also get reset to 1, because we cannot make a conclusive decision out of these two elements which one will be the majority element. And let's give space for 4 being a majority element over 3. Let's proceed ahead. Next we see is 5. Is 5 equal to my majority element? No, it's not equal to my majority element. As a result, what would I do? I will simply reduce the counter back to 0. Since counter has been reduced to 0, what should I do? I should reset my majority element. So majority element gets reset to 5, and count also gets reset to 1 by virtue of we attained 0. Out of these three rather, we can't decide the majority element. Let's proceed ahead. Next we see is a 3. So is my majority element equal to 3? No, it's not equal to 5. As a result, what should I do? I should decrement the count. So count gets reduced by 1, and since we achieve 0, we should reset the majority elements. So majority element gets reset to 3, and count also gets reset to 1, which is absolutely fine, because out of these 4 elements there is no majority element. So majority element will exist only if it occurs more than n by 2 times. What is the value of n up till here? N is 4. 4 by 2 happens to be 2. So we are looking for that particular element that occurs 3 times in the input array. It really doesn't happen to be this particular case. As a result, we have uncertainties. Let's proceed ahead. Next we see is 6. So let's check whether the current element happens to be equal to my majority element. 6 is not equal to 3. As a result, what should I do? I will reset the counter to 0, and since the count value gets reduced to 0, what will be my approach? I will reset my majority element to 6. So majority element gets updated to 6, and my count also gets reset to 1. Again, if you consider these elements, you cannot look out for the majority element as it doesn't exist. Let's proceed ahead. Next we see is 3, and is 3 equal to my majority element? No, it's not equal. As a result, what should I do? I will simply reduce my count value by 1, and it gets updated to 0. Since it got updated to 0, I'll reset the entire approach. I will update my count to 1, and let's assume majority element happens to be 3. Awesome, pretty straightforward, no rocket science. Again, in this particular array, we cannot identify a majority element because it really doesn't exist. Majority element will exist if it occurs 4 times. Right now we are not seeing any element that occurs 4 times so far. Let's proceed ahead. Next we see is 3, and 3 happens to be equal to my majority element, the assumption that we made, as a result of which count gets updated to 2, since we found out 2 consecutive 3s. And we have completed our iteration. What is the last element as my majority element? It happens to be 3, and this is what we need to return. I hope you're able to draw analogies between this and what I stated in the previous slide. It only works by virtue of occurring in more than n by 2 times in my input array. Let's take a slightly different case. Here the input elements are 4, 5, 6, 3, 3, 3, 3. And let's start the iteration so that you get a good hold of the concept. What do we assume? We assume 4 to be majority element, and the count variable will be initialized to 1. Let's proceed ahead. Let's start the iteration over these elements. Next element that I see is 5. 5 happens to be equal to majority element? No, it's not. The count gets reduced to 0. Since count gets reduced to 0, it's time to reset or re-assume the majority element. So count gets updated to 1 and majority element gets updated to 5. Let's proceed ahead. Next we see is 6. Is 6 equal to 5? No, it's not. Count gets reduced by 1. It gets updated to 0. And as soon as it gets updated to 0, it's an alarm that tells us reset the majority element. Majority element gets reset to 6 and count gets updated to 1. Let's proceed ahead. Next we see is 3. Is 3 equal to my majority element? No, it's not. So what do? We simply reduce the count to 0, and since count gets reduced to 0, we reset the counter of majority element to 3 and count gets updated to 1. And it's absolutely correct because over here you cannot identify any majority element. Let's proceed ahead. We see a 3. So is 3 equal to my majority element? Yes, it does. So we increment the count variable. Is 3 equal to my majority element? Yes, it does. I increment the count variable. Is 3 equal to my majority element? Yes, it does. I increment the count variable. As a result of which, what is the last element that is held in my majority element? It is 3, and it is in sync with our expectation. We need to return this result. Remember, why does it work? Because the uphills that you are taking will always be greater than the downhills that you will take in your entire iteration. And this is the crux of the problem, how this algo works. We call this algorithm Moore's voting algo. The time complexity of this approach is order of n, and the space complexity is order of 1. Let's quickly walk through the coding section and conclude it up. Here I have taken a count variable. Here I have taken the assumption that the nums at the 0th index will be my majority element. I start the iteration. I check if my current element happens to be my majority element, I increment the count, otherwise I decrement the count. In case my count happens to be equal to 0, I reset the majority element and the count value to 1. In the end, whatever majority element is left in my variable, that will be the result. And the rest of the approaches that we talked using the frequency map and the arrays can be done by you guys. I think it's pretty straightforward. This brings me to the end of today's session. I hope you enjoyed it. If you did, please don't forget to like, share and subscribe to the channel. Thanks for being it. Have a great day ahead and stay tuned for more updates from Coding Decoded. I'll see you tomorrow with another fresh question, but till then, goodbye.